As always, we're coming to you from Purdue University's John Martinson Entertainment and Engineering Labs. With us today is Matt Jordan. Matt is a product manager at PRG Scenic Technologies, where he designs custom mechanical solutions and products for live performance environments. With more than 15 years of experience across theatrical productions, tours, and special events, Matt brings a deep understanding of how technical stage systems move from concept to reality. I'm Mercer Applin. Of course, we've got our good friend Matt Jordan here. Matt, welcome.
Thank you.
Yeah, and folks, if you have questions for Matt during the webinar today, go ahead and throw those in the Q&A window, and I'll call those out and get to those as they best feather into the conversation. So if I don't get to your question right away, I'm not ignoring you, just trying to find a place to squeeze it into the conversation. So without further ado, Matt, it sounds like you've worked on some pretty amazing projects, from Broadway shows to tours. Do you mind sharing some of the things you've been working on and some of the cool problems you get to solve?
Yeah, I've got a slideshow I can bring up. Just a minute. So I work for PRG, which most people think about. Oh, right, that's where you get lights and sound equipment and blah blah blah. Not everybody knows PRG started as a scenic shop. Their first big show was Phantom of the Opera down on Broadway, and obviously Phantom did really well, ran for years, and that really bankrolled the owner's ability, like the founder's ability, to build out the shop staff, and then they started acquiring rental businesses and stuff like that. And so now when you hear PRG, you think, oh, the guys you get lights and stuff from. The original shop is maybe not in the same building, but the original core shop is still here, and we still service Broadway tours. Like, we build custom scenery and custom automation effects for all that stuff. And we've done some permanent installs, we've done some live event, like, goofy stuff. But we're always at the forefront of, people want bigger, crazier, like more tightly integrated, or like smaller packaging, because they need to fit more stuff in a thing. And like, that's, especially on Broadway, they're always trying to push the envelope of like, oh, what's like the next big thing? Like, what's cooler? And, we end up being one of the shops that is able to design some of that stuff to make that stuff work. So I'm gonna kick over. I have a couple of shows, or a couple of effects from shows that I can kind of look at, and we can talk about from when a show comes to us. Sorry. So when a show comes to us, we're obviously working with the production team. We work through like a project manager who's helping to manage requirements, this and that. But the show carpenters are the people that we really work tightly with. They're the people who, are kind of them and the technical supervisor, who are akin to technical directors for Broadway shows. They're really the ones who are like, oh, like, these are what the designers want, and they kind of the intermediary between what the designer wants and then how the stuff has to go into the theater, how it has to be maintained and supported, and level of robustness, because the stuff needs to run every single day, and it might have to run for 30 years. Like, you don't know. You're kind of gambling on a lot of these shows. But some of them run a really long time, and you need the stuff to be able to repeatedly run, be accurate. And if there are any problems, you have to be able to support really old equipment. And you have to be able to get a fix down, usually the same day or next day, because if they have to cancel performances, like, it's a lot of money. So anyways, they end up being the big go-betweens. So a lot of this, when we look at some of the stuff, which I'll pull up now, hopefully you're seeing this.
Yep, we got you.
All right, great. Advance. There we go. All right. So I grabbed a smattering of projects. There's, as I was telling Mercer earlier, like, there's so many projects, like, there's just too much stuff to. So I kind of picked my favorites. They're not the newest shows that we've worked on, but hopefully they're far enough back that like nobody be like, oh, they're giving away our secrets or blah 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 blah. So the first one of my favorite shows, actually, just because it was so damn funny, Something Rotten, 2015 on Broadway. There was a theater unit for this that you can see in this picture in the background, kind of the rough scale of this thing. Um, I believe this was in the St. James. Anyways, Broadway theaters, traditionally actually pretty small houses, not a lot of space in the wings, not a lot of space upstage, not a lot of room in the trap room, and we'll get to that later. But in this particular one, so they had this big house that they wanted to track upstage and then flatten against the back wall of the theater because they had other scenery and drops they had to fly in. So the show carp and I, we were looking at this, and he's like, "Well, these are the different positions that the designer's drawn it in." So you can see in the upper left is the like flattened storage position, and then it puffed out into the closed position, um, and then it would be able to open up and like kind of articulate, uh, so that they could do scenes inside, and it's kind of replicating the old Globe Theater, in a stylized way. You'll notice my model actually skips. This was all complex, uh, bent like it was like thatched roof. So some of these we don't have in there, but it's a thing of like how much time do you spend modeling something that the scenic artists are just going to carve, and how much do and usually it's as little as you can get away with, is what you do to be able to get stuff out to the shop floor. So just looking at a ground plan, just to kind of get a sense of scale. There were two deck tracks that this thing traveled upstage and downstage. And you can actually see we had to run electrics through those along with control automation. So they had cable chains, or cable carriers that ran in the deck tracks. An interesting thing, and we'll see a quick thing later, but one goofy thing about this is that for install and maintenance and that, they actually had to unknife this unit and then
Oh.
roll it off stage. The problem is if you have a bunch of automation cables that are coming up into the unit, how do you do that? And if you do that, how do like you're going to roll this piece of scenery over top of all of those cables. So these dogs were actually designed, the bit that fits through the gap in the stage, they were designed to flip over. So there were
Oh.
traps upstage that you remove the traps, and then you could basically undo all the cables, feed them down into the trap, flip that chimney for the dog over, close the traps, and then wheel the thing off stage.
How
Um,
frequently did they have to do the full disconnect for
it
maintenance?
wasn't a lot. It wasn't that obvious. Like it didn't happen during the show. Just even think about like unplugging all those cables and everything. Like, and we'll see the automation that's in here later. Um, it's a lot. It would be a lot. Um, they wouldn't want to do it for every show because I mean the goal of a lot of this stuff, automation on Broadway is like it's cool. You can do really neat things and just visually it can be really spectacular. But the other part of it, like they it sounds terrible, but the productions don't want to pay to have like 50 stagehands that can wheel stuff on stage and that. Like they would rather pay for one operator that can, hit a button on a control console. But that affords you repeatable, predictable movement. And there are just, less variables involved in that. But again, everything needs to be able to work consistently, and be robust enough that it works show after show. So just breezing through these ground plans, you can kind of see the different positions. Um, and you'll note, so there's an articulation here. I can't pan. There was an articulation here, which, and then same for the other side. And those were controlled via linear actuators. And then the storage position, and we'll see more in detail later. Actually, I'll go over here. So there was actually, we basically built our own rough linear actuator, these beams that would extend out and allow the geometry of this whole thing to kind of widen out and flatten Um, so, so yeah, you can kind of see they like extend out. Um, so go into some rough 3D models. You can kind of see talking about those extensions. Um, these were 2x6 beams. We ended up, let me see if I can get a little sketchy sketch going here. Um, so these are beams that had uh, linear guide rails welded to them, and we had bearings in these locations. So they could take that upstage, downstage moment acting on that arm. Um, so that when it moves out, and the whole thing on each side, you can see here, there's a sketch went away. Well, I guess it's not coming back. There is a kind of the drivetrain mirrored on both sides of the stage, where it's a simple F series gearbox, a parallel gearbox, long shafts, and then we actually did spur gears on the back of these that would drive these back. So like we created our own rack and pinion system for this. Um, and the and one consideration with all this was syncing everything up,
Mm.
because you think about like you need this thing to be able to be consistent in its movement, because if it gets off a little bit, it'll start to rack things, and then you're going to
Mm.
overstress, and it's no bueno. But then there's
Do
also
you
a
have,
certain. Oh, go
sorry
ahead.
to interrupt, but do you have the opportunity or during your design and build process, what is the kind of prototyping or tire kicking procedure like? And is that done primarily, first in computer modeling and then in, tried out of steel, or how does that process work?
Um, so a lot of times we build the prototypes, like the prototypes, what's on stage. We're very lucky that our shop floor staff that we have, there are a lot of people there that they've been doing this for a very long time, and they're super experienced and just really good. Um, the projects where I'm the most successful are ones where I go out onto the shop floor and, I mean, stepping back, you talk through with the show carbs, which these guys and gals, like they're no slouches. Like there's a reason that they're doing these huge shows, like on Broadway and these like national touring gigs and stuff like that. They're generally by and large, they're really good. So they'll have an idea of what's going to work and what's not going to work. They're also managing the risks. Is
Mm.
If you think about every decision that you make when you're doing a technical design, you're weighing, the risks, with, how well you think it's going to work. You know, so you may have some wacky, crazy idea, but that, if that goes wrong during a show, like they got to cancel the performance. So it's like the risk might be too much.
Mm.
So, you work with the production carps, even our PM staff, other designers in the office, kick around ideas with them. And then, I'll go out to the shop floor and I'll talk with those guys and we'll like sketch out ideas and this and that. And yeah, then it's getting into CAD, um, playing around. And hopefully by then at that point, like that initial ideation phase, you've kind of worked out the rough like shape of what you're going to be doing, like what the rough
Mm.
solution is. And there are a lot of times because a lot of our concerns are packaging, it's packaging stuff small. Like this is actually a lot of space, that I was able to fit all this stuff in, which we don't always have. But, um, you know, one of the things we run into is like sometimes I just have to get into CAD and get the parts in relation to each other and be like, how am I going to glue these together? Just because space
Mhm.
is so constrained. And it's like, you don't know exactly what the solution is until you start modeling stuff. Or if it's simple enough, you're doing 2D drawings. But a lot of times we resort to 3D modeling just because packaging is such a concern. Um, and yeah, then we'll do reviews with the shop floor, drawing reviews, production. If everybody's comfortable, generally we'll just go ahead and build. And hopefully in the schedule, we've left enough space for the test and adjust period where we'll set up, decks, full units, fly units, like almost everything that comes out of our shop, we set up. and we do rigorous testing on it to make sure that it's going to work. And there are a lot of times where we'll test and guys will be like, like this, doesn't quite. And so they'll make whatever adjustments are needed. A lot of times coordination with design, we'll make the fixes to it, and then, it's ready to go down to the show. But again, we're not making 1,000 of any of these. Sometimes I wish we did like mass runs of things, because then you could really optimize your design processes, your manufacturing processes, your testing like. But a lot of times it's like we're building the prototype, and that's what's going out on stage. So
Gotcha.
yeah,
Thanks for answering that. Sorry to derail you.
no, it's fine. Um, that's great, actually. I love these questions, because otherwise I'm just going to yammer on about stuff that people may or may not be interested in.
And that's a good setup, folks. If you have any specific questions for Matt, do feel free to throw those in the Q&A window, and we'll rattle those off as soon as we can.
Clear my
Back to you, Matt.
Right.
Sorry.
No, you're good. So here's just another shot of this boom arm extending. And you could see just kind of the geometry of what we had to fight through to get this thing to work. This is actually something that we had done at when I was at CATF years ago, Contemporary American Theater Festival down in, is it West Virginia? Years and years and years ago. We had some doors that had to open, but the mechanisms were behind the doors. And we ended up going, all right, we're going to do a linear guide pneumatic system, but they had these curved arms that let it open around the corner. So kind of stole that idea, beefed it up a little bit, and that was kind of the main actuation for this. Let's skip forward. There we go. So just looking at the actuators, so you can see here, I talked about the linear guiding. Obviously, if we had our linear actuator here that we just mounted to the end, it's just going to go willy-nilly. It's going to break. So we built a secondary linear constraint system, which ended up being UHMW blocks on a machine clevis. And so that kept that in line, so that, the forces wouldn't, the moment acting on that isn't going to spin it out. And then, yeah, so this linear actuator actuated this pivot, and there was a second linear actuator here that did that first articulated knuckle. And these actually, these were left over from a production of Ghost that we had done, which you should look it up. I didn't see the show. It didn't last very long, so take that for what it is. But they loved it in Germany. So it was probably one of the most heavily integrated productions we've ever done. Like everything was video walls, and like everything was tied to everything else. So if anything went wrong, it was like, well, like we got to close the like we have to shut the show until we fix it. Just because like there would be walls that would, tilt out, and then there'd be another piece of the wall that would spin out, and then another one, and then like there was like, a Pepper's Ghost effect in this wall, and the whole thing was covered in video, like custom video tile, not even tile. They were like these like strips. But we had a bunch of these actuators left over, and I'll say, if you're ever designing and you find yourself going to linear actuators, just be wary. It's often replacement for them is way longer than you have, especially if you run into show support needs. So this one here, the blue one, it's a little out of place. We had one there that was left over from Ghost, and due to the manufacturing, it was like a conical fit. And so if you pulled too hard, it would pop out internally. And once it did that, it was trash. And, we called up the manufacturer, who will go nameless. And we were like, can we get a replacement? They're like, oh, it's 8 to 12 weeks. Well, this unit's not running right now. So we ended up purchasing a Duff Norton off of, it was Granger. And we're like, well, they're dumb, and they're, but like they have them in stock. And we ended up taking off the DC. Normally they're just like 120 or 24 volt. You send it voltage and it just We took the motor off, we custom made a motor adapter, and we fit one of our smaller servo motors to it. And that's what we ended up installing and just running the show with. Because again, from a
Hmm.
show support perspective, like those are on the shelf, they're easy to get. So just if anybody goes down the route of thinking about like, oh, we'll get this wacky thing to get some spares, please. Like your show support staff will and your production will thank you. Um, if not, the other thing that I worked with somebody years ago who told me is when you're designing something, always leave a way out.
Hmm.
Don't design yourself into a corner. If it's such a like custom thing that only one thing's going to fit in there, like if it doesn't work, if they get out test and adjust and it doesn't work, or it breaks on site and you can't get like you're kind of screwed. Like so, um, yeah. Anyways, uh, just rambling. I think yeah, I'm gonna skip on. If other than that, like the rest of this were just scenic flats. If anybody
Hmm.
cares about the scenic part, heavily dressed, heavily, but yeah, those are kind of the main mechanics in this. I think I have a shot of the dog. I had mentioned the dog. Yeah, this was our one of the cable dogs that this portion here, the chimney that stuck up through that all the cables would pass through, this thing actually flipped over 90 degrees. So
Oh,
um,
I see.
I'm gonna pop on.
I've got
So
a quick
oh,
question for you
yeah.
from the audience.
Mhm.
What is the normal timeline of when projects reach your desk to when they're actually implemented and delivered, and kind of how does that vary in terms of the breakdown between Broadway and touring shows and other kind of special
Mm.
events?
Uh, it does vary. It so we it depends on how complicated it is, which sounds like a dumb answer, but um, there are so typically for Broadway show we'll have it seems like the time frame is shortening for the overall production, at least from when the production awards the bid to whatever scene shop's building it. A lot of times they'll split it out amongst different shops, but 8 to 12 weeks, and 12 is kind of being generous. And when you break everything down inside of that, that's from receiving everything, kind of clarifying requirements, which can be an arduous process. Um, because designers and directors and that may not think about specifications in the same way that we do. Um, and so trying to get clear answers can be a little difficult sometimes. But and then you've got your design process and then client review, which normally takes longer than you would like. And then you've your build process, test and adjust process. And like once you start stacking all those, like 8 to 12 weeks isn't a ton of time, especially when you
Right.
get to the bigger stuff. So if we're doing travelers, like simple traveler, just scenic units move across stage, they have like cable machines and that. We've done a lot of work over the years of trying to standardize parts of our equipment. So our machines, we have a ton of custom machinery, but we've picked certain ones and designed new ones where we're like, okay, great, we need this form factor. It's going to have this type of media, and this is roughly what it needs to move. We're going to standardize this so that we can build 10 at a time. And which again, it'd be great if we could build 1,000 at a time, uh, but that way the Lego blocks that you're building with. Um, uh, and things like traveler carriers, trolleys, like all the attachment brackets, the turnaround pulleys, like for a lot of that stuff, we've built out systems of these Lego blocks
Mm.
that we can connect together and we know they all work together. We can use them in a variety of configurations. That can be, even with all of that, that's probably for a simple traveler, it's probably like 2 to 3 days to go through design. Um, and a good portion of that is, again, trying to get client requirements of like, well, what's
Mm.
your fly, what's the widest this thing could be? Like position of the winch, like, does it have to hang off the side, be above? Like, how far do the panels need to travel? Do they need to buy part? Do they need to pass by each other? Um, whereas when you get into some of these, like this thing, oh, this was probably 3 weeks of my life that I'll, never get back. But I have drawings of it. So, um, some of the other breeze through, just kind of preview. This is a turntable we did for Frozen that is packed to the gills. You can see a person here, one of our lovely PMs for scale. It is packed full of stuff. This was probably a month of my time, maybe a month and a half. And then there were other people designing subsystems. And then there were people designing the control systems that went into this. Um, so it really varies. We've done stuff for some theme parks, who I probably can't name for legal reasons, just because that's how they roll. Um, those can stretch even like simple, like, oh, we're just building a deck. So you're building a deck in a theme park. That's a whole different level. You you could spend 6 months on that, and it sounds like, what are you talking about? Like, it just, but for theatrical stuff, like that's kind of those are a range of typical time frames. Again, we are a commercial shop, so we want to get stuff designed as quickly as possible, just so we can increase the throughput of the shop floor. But the shop floor only has so much capacity, and then design only has so much capacity, and our purchasing department only has so much capacity. So it's something that we're always trying to balance of like, we can only take on so much work on the shop floor. So, we can only give so much work to the technical design team. So it all ends up balancing out. But hopefully that answers that question.
Yeah, that was great. Thank you.
Spinning on, I'm going to check my time. Okay. So just breezing. So Tina Turner musical, another one, not super new, but I thought it was unique enough. This is, I don't know if anybody saw the show. I think they're doing a tour, but they're not doing this, and which will become apparent if it's not already apparent. Large, I think it's like 20 foot by like almost 9 foot tall wall that would rise up out of the deck. And um, the whole thing about this is, I believe this one is 11 inches deep. So you think about like, oh, okay, I've got this big like frame rising up out of the deck, and it's like they're going to take different scenic walls and insert it into this to represent different locations throughout the show. And there are doors in it. And they'll be slamming the doors, and like there's other stuff. And it's like, oh, well, now we're like resolving this moment on this very narrow, very tall, very wide thing, also pretty heavy. So this one, and this we just kind of solved with application of big dumb steel. Actually, it's not huge dumb steel, but and again, I had said that the theaters on Broadway are notoriously small for what we put in there, especially now that we're getting bigger and more complicated stuff. They so the theater this went into, they actually had to excavate the concrete, and I don't think this one they hit bedrock. There are some other theaters that they've done this for that they actually hit bedrock, and then they had to keep going, and that's a miserable process because bedrock is very hard. But yeah, they had to excavate into the trap room floor to get the travel that they needed to for this thing. But keep on. Oh, I got to clear those. Sorry, Zoom is not my forte. But yeah, so here's an overall. We had. I'll just skip over this way. So we had, yeah. So we're these big steel lifting towers that had machines in the bottom of them. There's a big like spanning beam that we had run across. Oops, skip right over here. That would take most of that load. When this thing was down, so when this thing was up, and there wasn't a door in there, this surface ended up being the show floor. When this thing was down in the deck, the top surface of this thing was the show floor. So it had to be able to withstand pretty good loads of like scenery rolling over top of it, people just walking, um, this and that. But the we ended up going, so we have a lot of this was custom built. We had some extrusion, some like large rely beam extrusion. It's meant for um, like rental stuff if you're spanning large. We had some of that in the lower building, and it was like instead of building a truss work and all that, it's like, man, that's labor intensive. So we just ended up taking some of this aluminum, this large aluminum extrusion, making these custom steel uh, like end adapters, and then bolting everything up, which allowed us to attach all this bracketology to my favorite thing for lifts, elevator rail. So you can see here, mounted on the front of this frame, we welded in some elevator guide rail, and then we have some purchased elevator guides. So that was really resolving the entire moment of this thing. And you can see the orientation of this beam, when it goes across stage, tall side this way to take the vertical loads. And then you'll notice when it gets to the side, it spins the other way to be able to withstand more, just to reduce the deflection, because this thing is pretty tall for how skinny it is. And then we use caliper brakes a lot on elevator rail, just to grab as a safety. We'll have brakes on the machines themselves, but then you've got the lifting media. In this case, it was I think, number 80 chains. You need something at the piece to actually hold it, just in case one of those chains breaks or whatever. Yeah. And then the nice thing about this is it was mostly a bolt together solution, using purchased parts, or we cut out some custom parts on the laser. I think at the time it was the water jet that we had. Put everything together. Yeah, and then this piece came in and dropped in, and you can't really see here, but we had these mounting plates here that there were 4 Destacos on the ends of each wall. And that's when they rolled them in the trap room, they would attach the Destacos, and the whole thing would lift up and, rinse and repeat. I think the show carp it was basically like a stack of walls on the upstage side in the trap room, where it was just like a whole ballet down there of
I'm envisioning
arranged.
the door garage from Monsters Incorporated as you described that.
It was similar, yeah. And he had to reuse some of them, so it was, God bless him, it was a feat of orchestrating everything. But I think the only other thing really, so just the top, so the bottoms of these I mentioned, they excavated into the concrete, and then anchored down to the floor. So, everything was secure there. And we actually embedded steel plates on the underside of the deck, secured those, and then the tops of these columns bolted to those. So there were these 2 incredibly rigid columns that had these machines mounted in the bottom of them, which were just simple gearboxes with a couple of drive sprockets. And, it's just, yeah, again, rigidity was the name of the game on this one. So, and then continuing, these are actually from the same show. They had similar things, door lifts. So I think this was 8 inches deep, about the same height, a little bit shorter. But they roll different doors into them, lock them into place, lift them up, bring them back down, switch out the doors. So this is a much smaller scale, but again, like resolving that moment load, that was the big thing. This had a similar approach. Well, I had said we've standardized some of our machinery over the years, and we're increasingly doing. One thing we did for SpongeBob, I believe it was, we kind of took a lot of our previous 2-post lift designs, which is this kind of chewy center of this whole assembly. And we standardized it and modularized it so that we can extend the length of it. And you're literally can take it apart, cut the rails down, reassemble it in a shorter configuration, um, which is something, they used to cut them down, and then when you got it back, be like, oh, it has to go in a larger theater. They would actually weld on extensions, and then so you have this lift that the rails kind of like kink. Like it wasn't great. So um, this is a much better solution, but it means that we can now take the standardized thing that we can bolt to, like we can start developing accessories or building frameworks that go around it. So in this one, rigidity, big concern. We had these big, I think they're 3x3 or 4x4 steel tubes, just big base plates. And those both supplied the main structure to resolve those moment forces. And then this was just purely the lifting mechanics. Um, so,
You mentioned that for the previous kind of larger lift system, and
mhm.
presumably for these, that obviously this is not a practical touring solution, right? I can't imagine any theater or any touring schedule has
No.
excavation time built in.
No.
I'm curious, and this is a kind of partially a question from the chat. What's the thinking process or the adaptation process that you go through in collaboration with a design team for translating a Broadway scenic design into something that can realistically tour, and kind of what is that negotiation and those trade-offs like?
So that, luckily, a lot of that work happens up front, on the production side. Especially there are companies that tour, like that's what they do. You think about like networks, or I think it used to be Troika, but like that's what they do is they tour stuff, and their staff, technical directors, in that they'll work with the productions, or maybe they buy the rights to the show and like, great, we're going to do, like, they kind of know what can tour and what can't tour. So a lot of that work's already happened up front. Um, when you're talking about first national tours, like like Tina Turner, I don't actually know the process. I don't think we built the tour for this, um, but you know that's normally it's a different organization. It's normally the technical supervisor. Or, when you get into the business stuff, and I'm kind of like, I don't care. Um, but but a lot of that work happens between the designer and the technical supervisor team, because they'll have an idea of like what can and can't tour, and a lot of it comes down to money. Um,
Mm.
you think about, you know, what venues are available to fit in, and it's like, oh, okay, well, these venues don't have traps, or the stage is only so big, or maybe the back wall is kind of short, or the proscenium's a certain size, and um, they have a list of like what shows they can go into, and or what venues they can go into, and obviously the larger that list is, the better for the production, like, just more possibilities to go into different
Mhm.
places. So as part of the design process, they'll normally take that into account. So we'll see shows come in where we're bidding on them, and they'll have extension decks, so that you can expand the apron to a wider footprint, or also, or, oh, we have to take off 2 rows so that we can fit into these 4 other cities. Um, lifts, I think, are probably one of the first things to get cut. It's a little hard. It's hard to go into a venue and be like, oh, you have to cut a hole in your floor to like fit this thing in, and it has to fit in this spot because that's where the lift goes in the deck. Um, well, maybe only 2 theaters will be able to accommodate that, and if they do, the you know you're going to have to pay for somebody to go in beforehand, cut that out, like do reinforcement and everything. Show goes in, show goes out, and then somebody has to go and restore it. And it's just like, it might not be worth it from a financial perspective, for them. So, but the other part of that too is, when you're touring a show from the production side, their load in time, load out time, super critical. Like maybe one of the most important things for them. Also, number of trucks. If you think about the cost of having, 6 trucks as opposed to 3 trucks that you're moving around the country for however many years, and you're paying the driver, and like it really adds up for them. So those are the things that they're always trying to slim down. And a lot of times this bigger stuff will get cut,
Mhm.
unless the design teams like, no, absolutely have to have it. But yeah, lifts are normally one of the first things that, like the Harry Potter tour, they they kept some of, because if anybody's seen it or that, trying to think how much I can say. There are some critical effects that are larger, um, where that kind of have this impact, and they're like, nope, can't cut it. Like, have to leave it in. So they left them in. And I think over the years, maybe they've scaled the show down a little bit, and they have cut some of those critical things. Not critical, but those bigger effects, because they're like, oh, maybe we can do it another way. But yeah, that's kind of the rough process. So by the time it gets to design, a lot of times they've already figured that out. And if they haven't figured it out, at that point it becomes a design exercise, which we'll do
Right.
with the production design team. Our bidding and estimation team normally will get involved, because at that point we're still pricing out and saying, at that point it doesn't become like, oh, design this. It's like, what's possible? And at which point, it's a whole different exercise. So
Right. It's negotiation rather than blind
yeah, yeah,
execution.
yeah, yeah,
Right.
yeah. And
Yeah.
because again, like you know, we're paying people to work, which is great. Um, you're like, well, we can't spend our wheels doing this for like 6 weeks just to like get you a rough, idea of what is possible. So, maybe it's like, I'll spend a couple of days like seeing if they can fit X, Y, and Z into this small package, or they have this effect that does this. Like, can we think of any ways to simplify it? So maybe it's a roll-on unit that's a friction drive, or yeah. Anyways, so that's normally how that stuff goes. Um, where was I? Oh, right. Lifts. Anyways, yeah, just a rough. So looking at these, oh, let's see if I can zoom in. Boy, not one with the zoom. The moment I had mentioned, the moment in here. There we go. We ended up doing. I was just wandering around the floor, being like, "What the hell do we have that we can?" So we did custom lift carriages that we had some large tube. I think it was like 8-inch diameter aluminum tube. I was like, great, we'll just make big torque tubes, and like that's just did a custom lift thing. So the lift is providing the vertical motive force, which was that I mentioned the chewy center, and then this kind of isolates that from normally the lifts would guide. You could see here these bearings engage with the side of the lift. These are normally what we mostly rely on. On this one, I was like, great, the travel needs to be pretty short, so we'll move those bearings close together, which doesn't give you a lot of moment capacity, but
Mm.
this is a torque tube, and we're getting our moment capacity by putting, again, my favorite lift thing, elevator rail directly on the side of
Mhm.
these honking tubes. Yeah, so it ended up working pretty well. Again, this, they actually had to core drill just around like these honking circular holes down into yeah, but it all worked out. Um, so those are like some things from Tina Turner. I'm looking, so we're at 12:45. I did have one thing I want to look at. So Frozen, I kind of mentioned this. We have this big turntable. It was actually a couple of turntables, and just do a quick breeze through. It was 2016. Went to Denver as the out of town, and then it went into, I think this one might have been St. James as well. Um, and they ended up blowing out the back wall. Remember, I mentioned the back wall was pretty shallow. Disney paid to blow out the back wall of the theater and extend it into the alleyway, which is buku bucks, but they wanted to make
Disney.
that investment. They got the money. So, and then sadly, the show ended up closing during COVID. But uh, so looking at this, just do a quick. So in this, there was I mentioned there's turntable there. is a secondary. Boy, I can't pan in here. Sorry, everybody. There's a secondary turntable kind of nestled inside of there. That turntable had 4 lifts that were synchronized that could go up and down. And then on top of the turntable, we had 15, we call them sloats. They're just little drop open trapdoors that slide open. And then inside of this, there were 15 of these little tiny ice bike lifts. And then, yeah, tons of power, tons of data, tons of control. I think the whole thing ended up weighing about 30,000 pounds, if I'm remembering correctly. So just going through, so obviously a lot of weight. We ended up building custom steel caster boards that we'd roll. They've got leveling bolts every so often. And because we were going down into Denver in an out of town show, and then it was moving to New York, we ended up trying to make this so that it was easy to install. I mean, that's always a goal, is just making stuff easy and quick to install and accurate. But a lot of this was like, oh, drop this over top and like be able to quickly secure this thing off. The most important thing is that they get the center point of this thing accurate, and everything else will, follow from there. But you can see shots of this setup in the shop, these custom steel bent things. Big, can't remember. Oh, yeah, pretty high capacity casters on these. Looking at, I mentioned there's an inner turntable. So there's the second ring. It's got these lifts built into it.
Are those sorry, in the previous plate, were those like equipment cabinets, like equipment racks built into
Oh,
the?
oh yes. We'll get there. So the
Okay.
yes, well spotted. There are equipment cabinets. Well, because here we go. We got some shots of. So you can see here. So we broke this up by color, and it's something we've done previously, just to try to visually distinguish like what's moving, what's not moving. Like, obviously, anybody who's going to go in, I think when they did this, actually both venues, but they walled off the entire thing. So like you couldn't even get in there unless you were a trained person who knew what you were doing. Because if you step off of here and the thing starts moving, it's a bad day.
Hmm.
So we tried to color code so yellow stationary base, obviously. Red is going to be the first layer of this turntable that can rotate around. Blue is the second layer that can rotate on its own. And then you can see inside of here these equipment racks. And then you'll see here, I mentioned that Chewy Center, the modular lift that we had designed. These are 4 of those in a different arrangement with different carriages. So all sitting on top of this thing, providing the structure for the top of this ring. The So you think about, you've got these 4 lifts, you've got another 15 additional lifts, 15 sloats, full power system, DMX. Like there was a lot of power that ran into this thing. These were the automation control racks for part of the system. I think for everything on this spinning part here. And then oh yeah, and then sorry, there's also the spinning of this was a chain drive that was built into the red. So sorry, like I said, there's as I went through, like I was like, oh my God, there's so much stuff in here. The Again, this is just another shot of that little chain drive, just a little custom, and you'll notice we do a lot of flat plate construction. We have the fortune of having, now we have a flat laser cutter, but at the time we had a water jet, which really, for those people with routers and water jets, benders, all of those like cool tools, like they really level up what's possible in terms of design. Like you think about making this like custom goofy thing, like if you're just doing stick goods and like plate that you're cutting on a bandsaw or like hacking away with grinders, like it's a game changer in terms of what you're able to do, what you're able to manufacture and produce. Um, but yeah, so those four lifts with the goofy lid, they actually didn't end up using this too much in the show. It was a little sad. But yeah, here are those equipment racks, and then you can see one of the commutators. There were actually two commutators. One commutator ran all the power and everything to the red level, and then the second one stacked on top ran all the power and control to the blue. Um, this is
That's
just looking
incredible.
up at that little drum on the inside. We actually ended up using ball hitches to secure this thing in place. You're synchronizing and the sync's good, but you don't want to rigidly connect any because then you're going to over constrain it. And again, you're going to have a really bad day. So these actually use ball hitches, and then we loosely captured them with pieces. Let me just breeze
Sure.
through.
Incredibly complex and incredibly cool, and what an incredible idea to do the color coding to make the kind of various moving elements really clear to see. We've got about let's say 5-ish minutes left.
Mhm.
A question for you that I wanted to get in before we wrapped is for early career folks or for students interested in kind of getting involved in this avenue of the industry, what are kind of the initial skill sets you're looking for people both on the design side and the fabrication side?
Um, I'm going to say for both, it's going to be time on the shop floor. Um, I think probably one of the most valuable, and Richard asked me something similar when I was there in October, November. I can't remember what it was. And I've been thinking about the answer since. And I'm like, I probably didn't answer that the best. Really, one of the most valuable things is experience on a shop floor, actually building stuff, having to repair things, like knowing, oh, right, if I put this together, I have to like be able to get tools in there to access that. And like, oh, if I'm going to do maintenance on this, like, um, or even having a sense of like how strong stuff, and there's calculations and things you can do for a lot of that. But a lot of times, it helps you develop a gut instinct for what's going to work, what's not going to work. Um, and like, it also helps you be able to talk to the people on the shop floor who are actually going to be building this stuff and who are going to have valuable insight and stuff you don't want to ignore. Um, some of it you might want to ignore, but mostly it's stuff you don't want to ignore because like they've probably, I mean, a lot of times we learn by making mistakes, and like, I've made a lot of mistakes. I know they've all made a lot of mistakes, but like that's stuff you learn from and you grow. Aside from that, communication, I think, and I know it's probably like oh, well, yeah. But man, if you think about even designing, like, sure, you're designing a problem, but like that's half of it. You're designing a solution, not a problem. Don't design problems, design solutions. Um, that's half of it. The other part of it is like you need to communicate that to people in a clear, concise, like simple way that they understand, unambiguous, and that's what drawing is. Like that's what creating technical drawings. It's like being precise and accurate, and like there's no mistaking how this is supposed to go over, like what the tolerances are, like um it's all about clarity of communication. And I think that's, yeah, those are probably the biggest things. After that, you get into like, sure, it'd be great if people knew how to do CAD, um, engineering analysis, even a simple broad overview of some, structural design for the stage, amazing book. Mechanical design for the stage, amazing book. Like, there's a ton of stuff in there that just chew on that, learn that stuff. They'll give you a leg up. I think probably most theater programs are teaching those, hopefully. Um, yeah, but yeah, I think those are probably the big things that would jump out at me. If people are just getting started and want to get, and Yeah, work in theaters and shops. That's the biggest because you're going to meet people, build relationships, and
We've
that's what a
reached
lot.
a natural stopping point,
Oh yeah,
but I wanted to say a huge thank you for coming on with us today and talking about kind of all of these amazing engineering challenges that you touch every day. Um, Folks, we'll be back on March 6th with Scott Pfeiffer. So join us on March 6th with Scott Pfeiffer, an accomplished architectural acoustician with more than 3 decades experience designing and evaluating listening spaces from performance venues to complex audio visual environments. Fellow of the Acoustical Society of America, Scott brings a rare blend of physics, music, and human perception to his work, exploring how shared listening experiences shape the design of spaces from the campfire to the concert hall. Scott used to sign my paychecks too, so that would be a good one to come back for if you're available next month. Um, uh, Additionally, early bird registration is now open for the 2026 Symposium on Education and Entertainment and Engineering. That's happening July 24th through 25th at Purdue and focused on turning real-world live entertainment industry practice into actionable teaching strategies. We'll drop a link for that in the chat if you're interested. Additionally, if you have any kind of follow-up questions that you want us to pass along to Matt, feel free to send us an email. We'll drop our Fusion Studio email address into the chat as well shortly. Again, Matt, thank you so much. What cool stuff you get to do every day. Um,
thanks for
and
having me.
Absolutely. Thanks, folks. I think we'll end it here and hopefully we'll catch you next month.